Okay, so we're just going to go through a couple of these problems and see if we can find a pattern. So here we've got a question. A store can increase its revenue by increasing the price of its t-shirts. The revenue R in dollars can be modeled by the relation R equals minus 50D minus 3.5 squared plus 4,000, where D represents the dollar increase in price. So the key information to pull out of this problem is what each part represents, because then when the question asks us about different parts, then we can actually like have a reference point, right? So the revenue R, right, is our Y value, and it can be modeled by this relation, and here's our other variable D, and D represents the dollar increase in price, right? So it's talking about dollar increase, and R is revenue. There's our key information. We're going to talk about revenue as our Y and the dollar increase in price. So they basically modeled this, and this is actually part of some of the a common problem where you might have to create your own equation where you talk about, oh, if we increase the price by $1, then then the number we sell will decrease by like 2, and then you can kind of model that relation and create an equation for it. But that's a separate lesson though. This has created the equation for you. Okay, so now it's saying what is the maximum revenue, and so remember our revenue is R. R is our Y value. So it's basically saying if this is a quadratic, what's the max? And what dollar increase corresponds to the maximum revenue? And so dollar increase, once again, is our D, which is our X value. So this is our X, this is our Y, right? So this is the when it happens. For all of these questions, it's just asking you about the vertex, right? It's asking you to graph it, fine. But it is asking about the vertex. It wants to know what is the maximum or minimum in the situation and when does it occur. Okay, so depending on the form of the equation, we studied all these different forms, we can get that maximum and when it happens in different ways. For vertex form, we would have to think about this form, ax minus h squared plus k, right? And our vertex is right here. It's at hk. So our statement is our maximum is whatever k is, which occurs when whatever h is. Okay, so I'm going to leave that for you to do from this form, which is in vertex form. Let's move ahead to question 10, and we'll see the exact same pattern, right? The path of a jet plane in training maneuvers is given by this relation. H equals something to do with t, right? Where h is the height in meters above the ground. Right, so that is our Y, the height in meters above the ground, and t is the time, there's our x. So again, we're sketch a graph. This is from factored form. At what time does the plane reach its maximum height? What is the maximum height? So once again, it's asking us for the max and when it occurs. So now we have to work from a factored form to find the vertex. The graph is a completely separate lesson. We did actually go over these, graphing from factor form and graphing from vertex form. Okay, so the maximum is when it occurs, right? So again, we have in factored form, we can quickly look at what the roots are. We find their midpoint. That's the when it occurs, or our axis of symmetry on the graph. And we plug that value back into the original equation to find what the maximum will be, right? And that's the Y, right? The maximum height. H is the height above meters in meters above the ground, so that's our Y, right? That's the max. When it occurs is our X. One more for question 11. We have yet a third equation in a slightly different form, and again, H is the height in meters above the ground, and so that's our Y. So whenever it talks about height, we're talking about the Y value. And then D is the horizontal distance in meters, so that's our X. Right, so it's going to be the maximum height when D equals something, right? So again, the question's asking us, sketch the graph. Okay, that's something separate. Note this is factored form. This D gives us a root of 0. Don't forget that one. People always forget that one when they're looking for the two roots. We still have two roots, just like in this previous factored form, we had two roots. So we have one here and one here. This one is given by D equals 0, and this one is, well, you can figure that one out. So at what horizontal distance does the ball land? So it's asking us what horizontal distance, right? So horizontal distance was our X. So our X question, does the ball land? And remember, when the ball lands, we know its Y value. And I'm not going to tell you what it is, but you know it. And remember, our Y in this situation is H. Our X in this situation is D. Right, so it's just a matter of matching the language as defined in the question to what this portion of the question is actually asking us. At what horizontal distance, so again, what horizontal distance, so at what x does the ball reach its maximum height? So here it's asking for the max. Once again, we need the vertex. What is the maximum height? Oh, sorry, so that's this one, right? This is the max, and this is saying at what x does it happen? So when it occurs. So for all of these questions, it's a matter of finding the vertex, except for part B here when it talks about it landing. We set our y value equal to what we know the height of the ground to be, and then we solve for x in a, well, I mean, it's factored form, right? So in factored form, it's quite easy to find when it hits the ground because we know the height is blank, and that means our roots are telling us a lot of good information there. I'm going to let you think about that one. But once again, going back to the vertex, it's nice when we can pull it out easily from vertex form. We can't always. We have to use the roots and their midpoint and sub back in. But either way, we find the vertex, our roots find their midpoint, sub it back in. And then once we know what the vertex is, if our vertex is, let's call it HK, we can say the max or min, depending on the situation, is whatever k is when x or is equal to whatever h is. Okay, that's the general statement that will actually answer most of these questions. All right, I hope this helps.